So, welcome to today's NFDI talk. This episode is about improving research data management with DAPHNE for NFDI. So, DAPHNE stands for Data from Photon and Neutron Experiments. And today's speaker is Bridget Murphy. Welcome. She works at the Institute of Experimental and Applied Physics of Kiel University and at the Deutsches Elektronensynchrotron DESY in Hamburg. She's also speaker of DAPHNE for NFDI. Welcome, Bridget. I will now hand over to you.
Oh, thank you very much, Natalie, for the very nice welcome. And I will start sharing the talk now. So, as Natalie said, my name is Bridget Murphy, and I would like to tell you today about what our work at DAPHNE for NFDI. And we're collecting data from photon and neutron experiments. And the work I'm presenting today is, of course, not just from myself, it's from all my colleagues who are working together within the NFDI, DAPHNE for NFDI consortium. So you're welcome to NFDE, and let's remind ourselves where we are in NFDE. So there are many different consortium, and DAPHNE is in the physical sciences. We're closely related to Fermat, to MARDI, to NFDI for CAT, Chem, Earth, and Punch, and also to MAT work. But actually, we're quite heterogeneous in that we cover a lot of topics around the famous NFDI horseshoe. So what we do with DAPHNE is we use neutrons and X-rays as our experimental probe. And we do a lot of experiments, including imaging, tomography, diffraction, spectroscopy, with both X-rays and neutrons. And these have applications in medicine, in life science, in physics, chemistry, and engineering. And we can see some examples here from health science, for example, protein crystallography, or from environment and energy, understanding how solar cells work, or from material science, for example, this beautiful ant that was imaged by our colleagues at Herion and DAISY, or trying to understand transport, for example, turbines from jets, and using this information to collect knowledge. So how is our community built up? Because we're quite unusual in that we are people who are working at all different locations, but what brings us together is that we use large-scale facilities. So the stakeholders are basically 115 research institutions, over 100 universities, and about 50 different companies. And this builds up to about a core of 5,500 users who use both neutron and X-ray or free electron laser facilities. These are large-scale facilities, so we prepare our samples or our experiments at home, and then we travel to these large-scale facilities. If you look at the map, you can guess where they are here at Hamburg, in Berlin, and in Garching. So out of our community, there's about 3,000 participants who do experiments regularly. We have about 3,000 experiments a year. And of the people who attend those experiments across our large-scale facility user meetings, we have an attendance of about 3,000. So we really get the community together on a regular basis. And this community is using 4 different sources in Germany, 33 sources across Europe, and around the world, there's about 94 X-ray and neutron and free electron sources. But as you can see, Germany is really leading the way. We're quite at the forefront of this. And one of the interesting things here is that all the experiments that are carried out at the large-scale facilities are previously peer-reviewed. So they already have a certain quality factor before they get to use the experiment. Another indicator for us that's quite important is that we collect really large volumes of data. And these are already a challenge for our community, how to use them and how to make them available for reuse. And before DAPHNE4NFDI, the research data management was mainly the responsibility of the users. And now what we try to do is to use our key position at the large-scale facilities to make tools available for the users and also to inform scientists who are coming to the user meetings. And we bring all the organizations together that are representing the users and the facilities. So as I said, we have huge amounts of data, so over 50 petabytes of data at the moment, and this is really growing. The community is quite productive. There are maybe over about 3,000 publications a year, and also quite a lot of patents also. So some of the sources which we're using are the European Free Electron Laser in Schielefeld, the Petroret 3 and Flash source in Hamburg, the ESRF in Grenoble, but also the MLZ in Garching, and HZB, the Bessie 2 in Berlin. So you see, we form a nucleus where we can use our knowledge and tools to reach out into the community. And our community is also a very collaborative community. And our users collaborate outside their own core field and often with people from other communities. So we see this also as a way of reaching out beyond the photon and neutron community, but also into the general scientific community. And with the aim of reaching a community of over 50,000, according to our calculations. So let's be now a little bit more specific about DAPHNE4NFDI. And DAPHNE4NFDI aims to make all photon and neutron data in Germany fair. And why do we want to do this? We want to do it because we want to enable better science. And for us, the focus or the measures that we have is the specification, so setting standards and the collection of metadata, providing curated metadata and data repositories, and providing also created repository of managed software. In order to make this sustainable and reach out into the community, of course, this requires education and training in research data management and tools. And to be effective, we need to connect into the other NFDI consortia, such as yourselves, and also to national and international organizations. And considering this aspect, this is where we focus on the German side of things, between the Committee for Neutron Research and the Committee for X-ray and Synchrotron Research. From the user point of view, and then from the facility point of view, then also the facilities within the German community, the large-scale facilities, which are mostly based at Helmholtz centers, and they provide research data management tools and structures. And we come together with this group of people, which is a collection of users across the universities and the Helmholtz, the large-scale facilities, so that we have DAISY. If we go clockwise, we say we have KET, Thüringer, Kiel, University of Berlin, LMU, Siegen, Aachen, Erlangen, Göttingen, Wuppertal, and then from the facility point of view, we have HZB, we have the EMBL, we have Herion, we have the TOM and Jülich. Together with Herion, they have the MLZ. We also have the Helmholtz Zentrum Dresden-Rossendorf and the European Free Electron Laser, and last but not least, DAISY. So our consortium brings together both the facilities that are providing the core scientific methods and the users who are using those facilities and the users who want to exploit the information and the science that's available at these facilities. So following on from that model, our research data workflow is built on this focus of when people prepare a proposal, then they come to a facility and they collect some data there. And this is our task area 1, where we consider managing data production. Then the data will be stored. We store both the data and the metadata, providing repositories and catalogues. This is our second task area. And task area 3 is evaluating such data, providing infrastructure for data and software reuse. So before DAPHNE started, there was no formal data management. Most people were using a paper logbook. And now what we do is we inform people so they know what the data life cycle is and explain and help them to follow such the life cycle. So for example, in the managing data production task area 1, here we're focused on the capture of the metadata. We do this through the control software that's used at the experiments, and also by defining common data formats that are used across the different facilities. The aim is to document the full workflow of the experiment using an electronic logbook, but also capturing all the information of the measurement as much as automatically as possible. And of course, to have a full record, we need to really define very clearly the parameters, not only of the data, but also of the sample that's being measured, of the instrument that's being used, and of the sample environment or the conditions that the experiment is being carried out in. So our recent achievements in this case have been defining electronic laboratory notebooks. We discovered that actually working at large-scale facilities due to federation and security and access issues and the rapid changeover of users, that it's very, very difficult to take some kind of a commercial logbook. So we spent some time defining requirements, and we have a number of prototypes that are now working at DAISY and at MLZ. Also, key to every experiment is the sample. And for this, we need to have persistent sample identifiers. For example, within DAPHNE4NFDI, our sample identifier, we use the ISGN system, which is available at University of Kiel. And just having logbooks and sample really doesn't help you to communicate across the community. And therefore, the data format is very important. And we discuss this with a lot of community discussion. And for example, the Nexus format, which is common across a lot of NFDI and other data-minded groups across the world. For metadata capture, it's really important that it's as automatic as possible. But before you get to collecting it, you have to have very clear standards. And this is very important for DAPHNE. Now that we've adapted these additions that I explain here for specific scientific use cases, which I will explain as we go through the talk, just a few examples of them. And now the next example we would like to do is then to have worldwide adoption, community-wide adoption. The second task area, here, this is where we deal with metadata repositories and catalogues. This is making the data fair, findable, accessible, interoperable, and reusable. So when the data is collected, we want to be able to curate it, to validate it, to store and archive the metadata, and also to provide access, to be able to share the data either open or in a controlled manner. It's quite common in our community that there's an embargo period and that the data will be shared. So about 3 years after the experiment is initially carried out. And for metadata catalogues, our main focus is on a catalog called SciCat. But we also have other catalogues, for example, ICAT. And these metadata catalogues are made available to all the scientists and the users at the large-scale facilities. And very important is that we adopt agreed common search APIs so that regardless of which catalog, we try to make the catalogs as similar as possible. But in the case that it's not exactly the same catalog, it's important that you can use the same search parameters to be able to use the different catalogs. We've come up with a lot of recommendations for SciCat, and we're one of the major contributors to the SciCat project, which is based at the ESS in Lund. The ESS is European Spallation Source. We also provide public metadata catalogues, 3 that are available or on the cusp of being available at the moment is the reflectivity catalog. This is available at public-data.desi.de. The EXAFS catalog database, which you can see is on exafsdb.ddns, and an XPCS catalog, which is will appear in the next week or 2. The moment it's available inside DAPHNE, but it will also be available externally. Also, we contribute to the European Open Science Cloud here with catalogs, and also to the Oscars project. So some highlights that we can mention here is that there's over 67,000 entries in the SciCAD instance that's running at DAISY. And these are, at the moment, these are in the embargo period, but as time goes on, they will become available to everybody. So we have a large test population in the public datas. We're still in the infancy stage. We have hundreds of datas, but we generate approximately about 3,000 really excellent data sets that are also published along with the publications in the year. And our aim is not only to curate all of the data, but in particularly to look after these highly valuable data that is associated with publications so that it can be reused throughout the community. In the third task area, we're looking to provide the infrastructure for data and software reuse. And what does this mean? This means that we want to provide access to curated analysis tools. So a lot of our experiments are carried out at the large-scale facilities, and this means that when we actually do the experiment, you want to be able to process the data immediately and then to store it and validate it. Before that, you even want to visualize it. So we look at it online, we do an online visualization and data reduction. And then in addition to the processing, then there will be further analysis. This can either be during the experiment at the large-scale facility where you're doing online analysis and data integration and following models. And in some cases, this work is carried out once the users are finished with the experiment and they go to their home institution. But in order to deal with these large quantities of data and to make life for scientists as easy as possible, it is our aim to try and help people to get as much of the data analyzed as possible before they leave the large-scale facilities. And some examples from this aspect are access to curated analysis tools. For example, our colleagues at EU XFEL have created a wonderful tool called DAPHNE, which you can download and test. This is for visualization and organization of data. It allows you to use Jupyter Lagbooks and gives a live data overview and run Python scripts on your data and view it. One example from the data processing point of view is so automated workflows and developed workflows is an example from Herion, from PyDDAS. This is a very nice diffraction analysis program. And building even further on that, going into artificial intelligence analysis pipelines, even to the extent of using closed loop experiments. Our colleagues in Turingen, together with some work from my group in Kiel, we're working on the Reflect Torch. And this can be integrated into control software and experiments so that you can do online analysis and with artificial intelligence. Very important, these are some individual experiments, but really the idea is that the developments are containerized and then platform independent. And one shining light, which of course existed long before DAPHNE, but DAPHNE is also helping with the containerization, is the CRISPR software developed at DAISY by Tom White. And so this is explaining what we can do. Now, these examples are in different use cases, or we call our flagship projects, going across from biomaterials, X-ray imaging, from tomography with energy and battery materials, correlated electron spectroscopy, soft matter and liquid interfaces, diffraction and spectroscopy, magnetic structures, dynamics, for example, XPCS, X-ray absorption spectroscopy, high energy diffraction techniques, neutron time-of-flight diffraction, and X-ray emission. Just to give you an example, or some examples in the field for how this works within DAPHNE, excuse me, I will highlight 3 of these examples here, the ones that are in purple. So I will start with the topic which is close to my own research area. And this is the data life cycle for X-ray and neutron reflectivity. It's a close collaboration between the University of Kiel, the University of Turin, and DESI, in particular, the colleagues Chen Shen and Florian Bertram at P08. And if you think about a sample, so we assume now you've written a very successful proposal and were lucky enough to be awarded beam time at a large-scale facility. And so you come with your sample, and how should the system look like? So your sample should be recorded, the workflow and the metadata, and you can record this in the ISGN system at Kiel and save it in the DataCite repository. And then with your experiment, when you're collecting your data, you document everything with the electronic logbook. And now the raw data, we will save it in a standard format. Our preferred format is the Nexus format. And at this stage, we have to save 2 aspects of the data itself, and also the metadata, of course, so that we can find the data back again. And this data is then extracted and reduced into a useful form. And at the beam times, we use a lot of automatic extraction and even machine learning predictions. This you can find here, this publication from Montanu, or in the publication from Linus Python. And once you have the data extracted, even beyond the experiment, you also, of course, would like to fit it and model it. And the aim is that not just the first part, but also this part of the data is also containerized and made available in a software repository, so that we have then the very high-end quality data from the experiment of the data, along with the fitting and the modeling, so that in the end, we have a publication which describes the experiment. We have the data, which is available at an open data repository. We have the software repository, which describes how the data was handled across all aspects. And we also have the core, the data, the sample metadata is also available, so that the whole process is fair and open. And this is implemented at P08 and also many of the other instruments where we do our X-ray and neutron reflectivity experiments. A similar example, but from the spectroscopy point of view, is the X-ray absorption spectroscopy. And again, you start off with a proposal which is submitted. And then when you come to do your experiment at the instrument, you have the metadata has to be collected from both the instrument and from the sample. And we save the metadata into SciCAD, and the data analysis, which in this case can be extremely complicated, is carried out and saved. Of course, all data analysis is complicated. And now the data is saved into the REXAFS database. And this is the open data repository. You can find the links here below. And what we provide here is a really high quality curated reference data. The provenance and the quality is fully assured. This provides not just for experimental, but also the foundation for machine learning based analysis tools. One last example then from the neutron side, but also a little X-ray, inelastic X-ray scattering. Once again, we start with a proposal management system, and then we move to the large-scale facility where an instrument is providing a method with particular settings. The instrumental control is recorded, and also the metadata is collected during the experiment, along with the complete history of the sample, how it was prepared, and the sample conditions during the experiment. And a number of events come out of this. First of all, the electronic logbook has automated entry, and as well as user annotations. This is the MLZ electronic logbook. We also collect the data and save the data and the metadata, again, in the SciCAD system. And the sample at MLZ, the sample history has its own identity management, which is also recorded and can be collected through a single sign-on, which also allows you to access the archive, and the data analysis is fully recorded, and the data is also published in an open data repository. So you see the flow is quite similar, but because we have such different methods and different approaches to our experiments, in each case, we have to take some very special considerations. So these are examples out of the use of the experiments, but of course, we want to outreach and disseminate this information. And the reason we want to do this is because we want to initiate cultural change across our own community and beyond our community into the close lying communities and beyond as well. And to do this, in the first 2.5 years of the DAPHNE project, we had 33 events, outreach events, and 9 of those were education focused at graduates or postgraduates. We are active in social media. We focus on our homepage, on the Zenodo community, and use the LinkedIn portal. It's really important for us to be active at the university level and to get into the university curriculum. And so we've introduced data management topics in curricula, providing lectures at different universities, lecture material for sharing across the community. And we have strong links to many of the current CRC and graduate schools that are funded in Germany through our direct colleagues and related colleagues. And additionally, we have our DAPHNE Vision Group, and this is an early career scientist network where the young scientists can meet together and also consider how they would get access to high quality careers, building on their experience in DAPHNE. We have many of task area meetings in person and reaching out into the community. We had a joint symposium at the DPG meeting this year with the FAIRMAT on pushing the boundaries of fair data praxis for condensed matter insights from workflows to machine learning. We will have a seminar in Bad Honnef in October this year, opportunities and challenges of fair data at photon and neutron facilities. You're welcome to apply and come. And from October, we will provide, as we've done in the last 2 years, a ring Vorlesung on the topics of synchrotron and neutron methods, and also how this is really related closely to high-level data and fair data approaches, and very praxis, really closely related to the practices that we use within the DAPHNE project. It's also important to communicate and link to the local environment, for example, to the physical sciences with the NFDI, with the MARDI and FAIRMAT, NFDI for CAT, PUNCH, CHEM, and CAT, and FAIRMAT. And we have a link across the national community to the IRM data community. This is the DGUM community, where many people from different kinds of large-scale facilities, astronomy or accelerator physics, are also working on providing high-quality data solutions, complementary and in synergy with that's what's provided at the NFDI. We have very strong links to Helmholtz. Many Helmholtz centers are a part of DAPHNE, and also to the DPG, as you see from my previous talk. And internationally, we have strong links to the European Open Science Cloud, and also to our respective communities, to the user community. the European Synchrotron Users Organization, where I'm the vice president in Europe, and the European Neutron Scattering Alliance, where Astrid Schneiderwind is currently the president, and also to the similar European collaborations from the facilities. This would be LEAPS for the synchrotron sources and LENS for the neutron sources. And linking into this community, this European community, is really important because this allows us, first of all, to make the kind of cultural changes that we were talking about, and also to mobilize and communicate together with the international community. And at the start of this year, together with the synchrotron and neutron users across Europe, we published a white paper, which I looked this morning, and it's been downloaded over 2,000 times now. So I think this is really a good way of getting out beyond your own small group within DAPHNE, but really reaching out across into the community. And I mentioned the EOSC Federation. So you will all know that the NFDI is contributing to the EOSC node, setting up the national node for Germany. And where does this fit into DAPHNE, or where does DAPHNE fit into the EOSC node? So what we are providing is the SciCat solution, the public minus data at desi.de, and this comes in two. We provided, first of all, within the NFDI solution for public data catalogues, but also the same solution is built into the PANOSC. This is the Photon and Neutron Open Science Cloud project, which is led by the ESRF for all of the large-scale facilities across Europe. So you see, we really want to provide long-term solutions and make the data available beyond our own community. And thinking of external communication and policies, it's of course key to link to the environment, and that's within NFDI. For base for NFDI, we are active in IAM for NFDI and PID. So the sync and share that we use at DAPHNE is the use case for the identity and access management. And we share a lot of our information with PID. Also, we are active across the different sections. I'm a member of the Senate, so if you want to contact me with questions about that, you can. And Lisa Emelung, who was previously with us and is now at NFDI, was a key member of the task force for evaluation and reporting. So apart from our external communication, it's also important to collaborate together with the physical science. And for example, we have booths at different symposia, and we have a common shared lecture with our colleagues there as well. So so the challenges and achievements that we face in the last time, we managed to bring our community together to define the needs. And now our aim is to provide beyond the solution demonstrators and move to establishing things in the community. So we've been working on community integration, community education and building. We've published 4 white papers for the community. When you're considering the data volume and complexity, we've been developing with our communities data pipelines and analysis software for dealing with the data pipelines and setting standards for these, and developing an integration within existing infrastructure for, in particular, the SciCat adoption, which is really very, very powerful way for using metadata, and is also an international solution. At the start, there was a limited research data management awareness, and now we provide data repositories, data creation, and workflow demonstrators. And as well as that, one of the key challenges is really, for all of us, I think, is how to get acknowledgement for young scientists. And definitely one way to achieve this is to provide data and software publications. So if we think about where we are with our research data management, how to make data fair with the DAPHNE for NFDI consortia, before we started, our community was fragmented. There was a limited awareness of research data management, and there was a kind of a haphazard mixture of paper and digital solutions. What do we have now? We have a community hub. We have standards that have been discussed and agreed upon. We have infrastructure demonstrators in key use cases. We have community software packages, and we have initiated a cultural change. And hopefully, in the near future, we'll get funding for DAPHNE for NFDI too. And what we want to move there is move to mature infrastructure solutions to get adoption by the wider community, to increase the capacity and the capability of the solutions that we provide, to explore artificial intelligence and machine learning solutions across all of the research data management, to work together to provide one NFDI solution, and also to provide good data for the EOSC national and topical nodes. And all of this is all together to provide a long-term sustainability and community-wide adoption of research data management, fair data across our community and beyond. So on behalf of our whole team, I would like to thank you. This is over 100 of us in March at our annual meeting in Berlin, and all of the names are here. And additionally, if you would like to have some more information, then you can contact myself, or you can also contact our project coordinator, Zeynep Iske Dürzen at desi.de. And with that, thank you very much. And I hope that you enjoyed my talk. This link here, the QR code, will actually bring you to the contents of the talk that you've just seen. So if you want to take a photo, you can. Thank you very much.
So thank you very much, Bridget, for this interesting presentation. With this, I would like to say goodbye to our spectators on YouTube. Our next episode is on 19 May with the topic OER.net, a hub for RDM for the humanities and social sciences. So I hope to see you soon, and